I'm Grandmaster C. You see me in such fine quality, epic physics videos such as What Does Rapping Have to Do with Physics? Part 4. And You Can't Force Me to Do This. Okay. This is chapter 6, looking at part B. This is kind of like a review and how to do one of the major problems dealing with forces. Now, anytime you look at a force, okay, there's two ways to look at it. It's either balance, which means all the forces around the object are zero and nothing is happening, nothing is moving, okay, because nobody is getting an advantage over the other. As opposed to if you have a force where somebody is winning, okay, there's an imbalance in the force. Or, in Obi-Wan terms, I sense a disturbance in the force. When you have a disturbance in the force, that means something is going to be pushed or pulled. In any way, an object moves. That's the idea with it. So, with that, a force is a push or pull. Now, we use the unit of the force as the Newton, after Isaac Newton. Baller! Now, a Newton is about 1/4 pound of push or pull on an object, roughly. That gives people an idea about that. Now, all matter is held together by forces. So when we're talking about atoms, we're talking about cells, organisms, all of those are held together by attractive forces. Here we go with hydrogen bonding with water molecules. Guess what? Those are attractive forces, and they have the application in physics as well. So with that, when we talk about forces, anything that we're doing, moving an object, operating a cell phone, canoe, rapping, I have no idea who that guy is, basketball, going through the hoop, all requires forces that are pushing or pulling in different directions. Okay? And with that, we can look at force in terms of vectors. Now remember, a vector, it's kind of like that funny looking little arrow that has a direction and it has a magnitude. Okay? So force is a vector quantity. So when we look at the forces on an object, it's the summation of all the forces, which is equal to force 1 plus force 2 plus force 3 plus force to the n, however many forces are acting. So when we look at this airplane that is flying, for example, you have got 4 forces that are working with it. You have the thrust going forward, you have the weight of the plane going down, yes, force due to weight, you have the lift, the force of the lift, because the plane's got to be kept up in the air. Now you also have the drag, which would be the natural friction that the plane is going through the air. It's cutting its way through a lot of air molecules, okay, and water molecules as well. So this is an example when you look at the total force. Okay, it's got to be greater than 0, otherwise that plane isn't going to move. Okay? So when we look at, ultimately, it's the net force that we're looking at. It's wonderful if you've got 100 different kind of forces acting on something, but all we care about are the net forces, because some forces will cancel each other out. Okay? So forces can be balanced or unbalanced, like I mentioned. Balanced forces, the total force is 0. Which means when we look at force in the x direction and force in the y direction, we have to look at all of those factors. They have to be 0 as well. Otherwise, the force is unbalanced. It could be, if it was unbalanced, it could be unbalanced in the x direction. It could be unbalanced in the y direction. It may also be unbalanced in both the x and the y direction of a certain magnitude. Okay? So with that, we can look at, as long as we have unbalanced forces, the total force is greater than 0, something has to move. Okay? King Julian and Sarge. Penguins of Madagascar, they're heroes. So we're going to go ahead and we're going to work on a problem. Okay? And what we're going to do, we're going to sketch the problem as well. So Luzario and his brother Punkwus are on opposite sides of the river of broken dreams. They each are pulling on a cable that are attached to a boat containing Luzaria's cat. Luzario and Punkwus are each pulling on a cable with a force of 150,000 newtons at an angle of 55 degrees on either side of the boat. What is the magnitude and direction of the sum of the towing forces on the boat? We assume the forces act on the same point on the center line of the boat. Okay, a lot of information here. We got to sort out stuff. What are the key things when you're problem solving? What's the information given to you that is relevant? Okay, so you go note that they're pulling on a cable with the force of 150,000 newtons at an angle of 55 degrees on either side of the boat. Just this part right here tells us most of the problem. See those first three lines? They don't matter. They just make the problem entertaining. But what you're looking at right here, that is a real piece of information. That's the info they're giving. Now the second part of solving a problem is, what are they asking? Okay, so here in blue, this is what they're asking us. Okay, what is the magnitude and direction of the sum of the towing forces on the boat? That's what they're asking. Now, we assume the forces act on the same point on the center line of the boat. That would be another piece of information that would be useful for us. So, if you notice, the first three lines here doesn't even matter. They're there to help set up the problems. Okay? So, with that, now we can go ahead and let's sketch out the problem. Well, when we sketch out the problem, you could go and draw a boat if you want. Okay, here's the boat, and you have got two cables being pulled by the guys along our river. Okay, so that's sort of what it looks like. Okay. And you have the kitty cat and loose area. I'm not going to draw that, okay? But the idea is, okay, now I got a rough sketch, but now let's break it down to what are the basic pieces, because this can look kind of confusing. So I'm going to go ahead and I'm going to make the square of the boat. It doesn't matter. And I know that I have two cables, and they're attached to the center line of the boat like this. Now the boat is traveling this way. Okay? Now, in the problem, what did they give me? In the problem, they said 55 degrees and 150,000 newtons. All right. So we have 155,000 newtons here. 155,000 newtons here, okay? And at this point, we've got to say, all right, we have this angle here of 55 degrees, okay? And the other angle pulled by the other guy is also 55 degrees. So this is what, so I went from this sketch to this bare bones. This is part of the analysis, part of the problem solving that you guys need to understand, that you need to acquire to be successful at this. It's not that 10 years down the road you're solving physics problems. It's 10 years down the road that you're able to problem solve. And remember the God who made all these natural laws that we all have to obey, pretty much. Okay? All right, so with that, now, we sketched out our problem. Great. Sketched it out. Well, what is the next thing that we need to do? Well, I'm going to erase all this because you guys don't have to worry about it. Okay? And if I click onto the next slide, it's going to show. So let's go with it. So we're going to draw out the force vectors and their angles involved. We did that. So what forces are involved? Well, force Lucerio and force Punk was. Notice I gave the names of the guys who were pulling on the cable so that there's no confusion. So then I went ahead and I said force Lucerio is equal to force 1. We're just doing it to make things easier. Here's the info. 150,000 newtons at 55 degrees north of east. Punk was F2, force 2. Same amount of force of newtons, same magnitude, but a different direction, 55 degrees south of east. Well, wait a minute, what do you mean? Well, when you're looking at this, I'm going to go ahead and draw that out over here. So here's your line going east, okay? So you have one cable pulling this way. Since it's pulling this way, this is north of east. When the other cable is pulled this way, it's south of east. So that's why I can sit there and make those directions with it. Okay? So this is our information. Now we're going to go ahead and move on to the next part. Okay? So we have that. So now we got to look at, okay, what's the total force on the boat? Well, the total force on the boat is force 1 and force 2. Okay? Because we have two force vectors working on it. So what does that mean? Well, F1 and F2, we have to look at the total forces in the x direction, the horizontal plane, and we have to look at the y direction, or the vertical plane. That's a pretty important thing to look at when you're looking at these. Okay? So with that, now that we know, when we're looking at the total force on the boat, it is force 1 and force 2. But we have to look at it in terms of x and y. Okay? So that's the total force on the boat. Now, total force in the x direction, so we're not worried about this. No, no, no. Yes, yes, yes. This is the x direction. Yes. Okay? F1 in the x direction plus F2 in the x direction. And we have to look at total force of the forces in the y direction. That's the one we're interested in. And then, no, not the x direction here. And that's F1, all the forces of F1 in the y direction plus F2 in the y direction. Okay? Now the question comes down to, okay, well, what are you talking about here of F1y and F1x? Now let's take a look at this. Let's break it down. So I'm going to go ahead and I'm going to say, here is my force 1. Okay? And it is at a 55-degree angle. Okay? Now, what are we talking about when we say force 1 in the x direction? Well, what's happening, this is a resultant magnitude. This is going to be the hypotenuse of our right triangle. Well, wait, why a right triangle? Well, remember, if you got the x part and the y part, they form that perpendicular, that 90-degree thing. Okay, so what we're going to do, we're going to go here. Okay? So this is our F1 in the x direction. Notice it's on the x-axis, it's horizontal. Okay? Now, what about the y direction? Well, the y direction is the vertical, that's going up and down, right? And notice I kept F1x in the blue, and here's F1y in the green. So that's what we have. Okay? Now remember, guys, we do have a second vector. Okay, so let me go and bring that in. Now we have a second one. Remember, we also have the boat going this direction, but we have a second vector, a second one that's being pulled, okay, and that happens to be F2. Now this is also 55 degrees, okay. I gotta look at my timing. So we got 55 degrees. So we have to look at F2 in the x-axis, and that's right here. This is our F2 in the x direction. Okay, again, notice, what do they have in common with each other other than they're blue? It's on the x-axis. It's the horizontal that you're looking at. Okay? Because remember, you're not going to get this without the x part and the y part, or the x component, y component. Okay, now, here, we're going to have our F2 in the y. Okay? Now, let's go with this here, and let's do some more labeling. So far, we've got our forces here isolated. Okay? We got our degrees. We have our magnitude. Now, if you look at it, in terms of a right triangle, this is our hypotenuse of our right triangle, okay? Because our perpendicular is right here, okay? Now, what is f of 1 in the x? Is that the adjacent or is that the opposite of our angle? Well, in this case, it is our adjacent, and this has to be the opposite. When we come down here, we look at the angle here. This is going to be our adjacent, and this is going to be our opposite. So in both cases here, our force in the x direction is adjacent to that 55-degree angle. The opposite component is our y component. Okay, I gotta move on here. Now we've set everything we're looking at. We need to find the value of each x and y component. So now this is where the SOHCAHTOA comes in. Okay, remember, sine opposite over hypotenuse, cosine is adjacent over hypotenuse. So if we look at f1 in the x, and we go back to our picture here, if we want this, it has to be the sine of 55 degrees, okay? That's the adjacent divided by the hypotenuse. Same thing with f2 in the x direction. It's going to be the sine of 55, the adjacent, divided by the hypotenuse, okay? When we look at the y, it's going to be sine, opposite over the hypotenuse. Opposite over the hypotenuse for both. Okay? So now this is why I've got all this. So here I've got 150,000 times cosine of 55 gets us 8630 north at the 0-degree mark. That's our F1 in the x. F1 in the y is 122,800. So our F1 in the x is this way, that's 86,000. Our Fy this way, the F1 and the y, is 122,800. Now with the F2x, we do the same thing. And now look, we're going to get the same value as F1 of x. Now, we're also going to get the same value of F2 in the y, okay? However, it is at the negative 90-degree mark because it's going downward. So that makes it negative. So now we're going to add those parts together. F1x plus F2x, F1y plus F2y. So now we're going to add them together because we need to see the total result. So here's what we get with F1x and F2 in the x. Here's F1 in the x, F2 in the x. This is what we get for the total of force in the x direction. Here we do the same thing with the y component, but you notice this one's positive, this one's negative. Guess what? They cancel each other out. That's a huge deal. That's huge for us, okay? So now we've got to move on here. So we're going to add we added out our components, and now for our final force, remember we got to use the a squared plus b squared equals c squared, the Pythagorean theorem, okay? Which is the square root of f of x, f total x squared plus f total y squared. Well, the y, here it's canceled out, so we're really looking at this. Squared. So it's 172,060, which we got here adding these two together. As we're rounding down, going third base on our way to home, slide DiMaggio, slide! We got our total is the square root of f total x squared plus f total y squared. Okay, so we did that. We took the square root of 172,060 newtons. We squared that because the 0 we don't care. So our total thing here is 172,060 newtons is what's pulling the boat. The direction, it's 0 degrees to the east on that. And with that, ladies and gentlemen, I am going to have to stop here. Okay? Take it easy, guys. I hope this benefited. Bye.